Hey guys, welcome to the 40th C programming tutorial, and in this tutorial we're going to be looking at floating point data types. And floating point data types are basically just used to store fractions. The only floating point data type that we know of already is called the float. So let's just go ahead right here and create our own float variable. So we're just going to say float f equals, and then I'll just set it equal to 3.5. And the size of a float in memory is 4 bytes. So after this, I'm just going to put a comment saying 4 bytes. Alright, so float, like I said, is the only floating point data type that we know of. And after float comes double. So I'm just going to put double right here. I'll call it D and set it equal to 5.2, I guess. And in memory, a double takes up 8 bytes. So I'm just going to put a comment here saying 8 bytes. And finally, after the double, our last floating point data type is the long double. So just long double, and I'll just call it LD and set it equal to 6.2. And then following this, I'll just put a comment saying 12 bytes, since the long double takes up 12 bytes of memory. Alright, so you're probably wondering what the difference between the float, the double, and the long double is. Well, the float is the least precise, meaning that it can store the least amount of digits. The float can only store 6 digits to precision. So that means that we can only store a number with 6 digits inside of any float variable. So we can just say 1.23456, and that's it. We can only use 6 digits in any number that we store inside of a float variable. And then the double has 15 digits of precision. So that means that we can store a number with up to 15 digits inside of a double variable. So we can say 12345.6789, 1234556. So here are 15 digits, and that's a pretty big number. So you can store almost any number that you can imagine inside of a double. And then if you need even more precision, you can use a long double, and the long double is precise up to 18 digits. So we can store a number with 18 digits inside of a long double. So we can say 123456789.123456789. So there are 18 digits. And usually whenever you're dealing with floating point data types, you're going to be using the double if you need something precise. You're never going to really need to use the long double, but if you ever need something that precise, it's there. Alright, so let's just go ahead and take a look at printing out these floating point data types. So first, let's just go ahead and print out the float. So we're just going to say printf %f for float, and then I'll just end that line. And then we're just going to go ahead and print out our float variable called f. So I'm just going to do f right here and end the line with a semicolon. So when I run this program, I should just get 3.5 out onto the screen. Yep, perfect. And remember, if I ever want to format this, so I want to edit the number of digits that will come after this decimal point, I can just do 0.2f, and that 2 basically just signifies that there are going to be 2 digits following the decimal point. So now when I run this, I should get 3.50. Yep, and if I obviously wanted to make it so there's only 1 digit after the decimal place, I can just change this to a 1. Now we should only get 3.5 out onto the screen. Yep, perfect. Alright, and if I wanted to print out a double, I don't have to change anything inside of here. I can just change this to a D. So we're now printing out our double variable called D. And I run this, and I should just get 5.2 out onto the screen, since the value of my double called D is 5.2. Yep, perfect. And if we want to print out a long double, what I need to do is change this to LLF for long double. And I'm just going to go ahead and print out my long double called LD. And when I run this, I should just get 6.2 with a bunch of excess zeros on the end. Yep, perfect. And again, if I ever want to format this, all I have to do is in between this % and this first L right here, I can just put 0.2 and then the number of digits that I want to appear after my decimal place. So I can just go ahead and make this, I'll make it 2 now. So when I run this, I should only get 6.20. That's it, no more zeros.